We're going to rewind all the way back to when you were in primary school. Do you remember that kid that always came last in the running race? They struggled to throw and catch, no matter how hard they tried. Always picked last. You might not have noticed, but they probably had to wear Velcro shoes, and they found it difficult to handwrite, putting them behind in class. They were bullied, and this put them at an increased risk for anxiety and depression. The child that you're thinking of probably had developmental coordination disorder, or DCD. It's the most prevalent childhood movement disorder, affecting approximately 5% of children, 1 to 2 children in every class. Now, we have a relatively good understanding of the movement difficulties that these children face, but what we don't understand are the underlying causes of this disorder, and this limits our ability for early diagnosis and early intervention. And that's where my research comes in. I'm exploring whether dysfunction of the mirror neuron system might be underlying the movement difficulties characteristic of this disorder. The mirror neuron system is a cluster of neurons in the brain that you can see in the brain in the middle of the screen. They fire when we observe and imitate movements. Visual learning is thought to be our main means of learning new movement skills, and learning by imitation is something that I, and probably most of you, take for granted. But early on in my research, I identified that children with DCD have deficits in imitation. They're slower and they're less accurate. So behaviourally, they're showing deficits that are consistent with mirror neuron system dysfunction. But what's happening in their brain? To explore this further, I enlisted the help of this rather large and noisy machine. It's called a functional MRI scanner. It allows us to non-invasively look at brain activation through looking at oxygen utilisation. I scanned children with and without DCD while they were observing and imitating actions. Now, we were really excited because we thought we might have uncovered one of the underlying causes of the movement difficulties these children experience. But actually, when we analysed our data, we found no differences in mirror neuron system activation. What we did see, however, was that children with DCD had reduced activation in the areas you can see in red, areas involved in motor planning and attention. Both areas that had the potential not only to impact imitation in these children, but the whole range of movement difficulties that they experience. I'm really hopeful that we can explore these findings further, but more importantly, that we can take these findings and translate them into the clinical movement programs that we run and improve the interventions that we're delivering to these children on a daily basis. Thank you.